Hello students, this question is taken from test series 1 EE from the subject power system, from the topic transmission and distribution. A 132 kV 50 Hz 3-phase 100 MVA transmission line is operating at full load 0.8 power factor lagging. It is nothing but 3-phase supply 132 kilowatt 50 Hz frequency from 100 MVA transmission line is operating at 0.8 power factor lagging, which is nothing but the receiving end voltage VR is 132 kilowatt and the frequency is 50 Hz. Sending end voltage of a transmission line is 132 kilowatt, which is nothing but the sending end voltage Vs is 132 kilovolt, and it is having ABCD parameters are A is equal to 0.8 angle 1 degree and B 25 at the rate angle of 35 degree. Which is A is 0.8 at angle 1 degree and B 25 at the rate angle 35 degree. Its regulation in PU will be. We have to find the regulation in PU. To find the regulation, in order to calculate the regulation, the formula to calculate the regulation is regulation is equal to VR no load minus VR full load by VR full load, which is nothing but VR no load is nothing but no load receiving end voltage and full load receiving end voltage, and VR is VR no load is nothing but VR dash minus VR full load is nothing but VR and VR full load is VR. When the load varies from no load to specific full load, the value of IR should be 0. The value of IR is 0. So the equation for sending end voltage in the ABCD parameters is Vs is equal to A into VR receiving end voltage at no load plus B into IR, where IR is equal to 0. So value of this becomes 0. Then the value of VR at the no load nothing but VR dash is Vs by A. The value of sending end voltage given in the question is 132 kilowatt by A is 0.8 at the rate angle 1 degree. After calculating this value, we'll get 165 kilowatt, which is nothing but the receiving end voltage at no load. So I had to find the regulation, that is regulation is equal to the receiving end voltage at no load, that is 165 kilowatt, minus the receiving end voltage at full load, that is 132 kilowatt by receiving end voltage at full load is 132 kilowatt. After calculating this value, we'll get 0.25, which is nothing but 0.25.